everyone. Today we will solve a problem related to Sylow subgroups. Let order of group is equal to 30 so that either Sylow 3 subgroup or Sylow 5 subgroup is normal in G. Second part is we have to show that G has a normal subgroup of order 15. And third part is we have to show that both Sylow 3 subgroup and Sylow 5 subgroup are normal in G. First of all, we prove part 1, which says that either Sylow 3 subgroup or Sylow 5 subgroup is normal in G. We are given that order of group is equal to 30, which is equal to 2 multiplied by 3 multiplied by 5. From Sylow third theorem, we know that the number of Sylow P subgroups of G is of the form 1 plus Kp, where 1 plus Kp divides order group. Here, K is a non-negative integer. From Sylow third theorem, we came to the conclusion that here the number of Sylow 3 subgroups is 1 plus 3k and 1 plus 3k divides 10. This implies that either k is equal to 0 or k is equal to 3. If k is equal to 0, then Sylow 3 subgroup is normal. Let k is not equal to 0, then k is equal to 3. This gives that 10 Sylow 3 subgroups Hi is of order 3, and so we have 20 elements of order 3. If I is not equal to j, then order of Hi intersection order of Hj divides order of Hi, which is equal to 3. This implies that order of Hi intersection order of Hj is equal to 1 only, and so these 20 elements all are different. And each Hi has one element which is identity element of order 1 and other two elements are of order 3. If A belongs to Hi, then this implies that order of A divides order of Hi, which is equal to 3. Which implies that order of A is equal to 1 and 3. But we have already counted 20 elements of order 3. Thus, we have more than 44 elements in group G, which is a contradiction. So, either k is equal to 0 or k dash is equal to 0. Which implies that either Sylow 3 subgroup or Sylow 5 subgroup is normal in G. Hence, the result is proved, which says that if order group is 30, then either Sylow 3 subgroup or Sylow 5 subgroup is normal in group G. Now we come to part 2 of this problem, which says that if order group is 30, then G has a normal subgroup of order 15. Now we prove this. Let H be a Sylow 3 subgroup of order 3 and K be a Sylow 5 subgroup of order 5. Then by result 1, we know that either Sylow 3 subgroup or Sylow 5 subgroup is normal in G. Then from result 1, we came to the conclusion here also that either H is normal in G or K is normal in G. In any case, if Hk is a subgroup of G, then order of Hk is equal to 15, and as order of H intersection K divides order of H, which is equal to 3, and order of K, which is equal to 5. This implies that order of H intersection K is equal to 1, since index of Hk in G is 2 and Hk is normal in G. This proves second result, which says that if order of group is 30, then G has a normal subgroup of order 15. Now we come to part 3 of this problem, which says that if order of group is 30, then we have to show that both Sylow 3 subgroup and Sylow 5 subgroup are normal in G. To prove this, we suppose that H is normal in G. By result 1, we know that either Sylow 3 subgroup or Sylow 5 subgroup is normal in G. Then G has 6 Sylow 5 subgroups, and so there are 24 elements of order 5. But order of H HK is equal to 15. This implies that HK is cyclic. This implies that HK has 5 15, which is equal to 8 elements of order 15. Thus, G has 24 plus 8, which is equal to 32 elements, which is a contradiction. It is not possible for G to have 32 elements. So, it's a contradiction. Therefore, K is normal in G. If H is not normal in G, then by result 1, we know that either Sylow 3 subgroup or Sylow 5 subgroup is normal in G. We came to conclusion that G has 10 Sylow 3 subgroups, and so there are 20 elements of order 3. From above, we came to conclusion that HK has 8 elements of order 15 and K has 4 elements of order 5. This implies that there are 20 plus 8 plus 4, which is equal to 32 elements in group G, which is a contradiction. It is not possible. Therefore, H is normal in group G. So, both H and K are normal in G. This proves part 3 of this problem, which says that if order of group is 30, then both Sylow 3 subgroup and Sylow 5 subgroup are normal in group G. Thank you and have a nice day.